Hey guys, welcome back to the channel. In this video, we'll be talking about the components that go inside of rational functions when we graph them. This is an introduction to the ideas of graphing rational functions, and this is really close to the end of the playlist. We combine everything we talked about from rational expressions and rational equations, complex fractions, and even real soon rational inequalities when we're trying to find the domain of these functions. So let's just hop right into it. All right, so we said in the very beginning, the parent function of a rational function, or the simplest form we could ever get a rational function, is 1 over x. And we know it's a fraction. All right, we're dividing by a number. We're dividing by any number, and x could be anything. But the problem is, all right, we have to exclude a value because we can't divide by 0. So this 0, uh, uh, this value for x cannot be 0 because if we divide by 0, it becomes undefined, and we cannot have an undefined expression in our domain. So, or ranges, of course. And so pretty much, this creates the idea of an asymptote. All right, and we'll talk about that more in depth. But pretty much what asymptote means, and uh, really this is an idea in calculus as well. When we talk about limits, all right. So the general shape of the function, all right, it's getting close to these invisible lines. Think of it that way. They're invisible lines, and they're trying to get close to them. They're trying to reach them, and they're not reaching them. Think of it as like a toddler trying to reach a shelf uh, full of cookie jars, and full of cookie jars, trying to get a cookie, but they can't reach the shelf. The more they try, no matter how hard they try, and how they will never touch it. All right, and so that's the general sense of a asymptote. The function, all right, from both the left and the right of this function, they're trying to uh, touch 0 horizontally and vertically. So if you look right here, it goes from the left trying to touch 0, and tracing it, and it never does. Tracing it, and it says nope, we're gonna go down. We get frustrated and we go down again, and it just says no, I can't reach it. So then it tries from the right. All right, as it's continuing right, it goes to the bottom and try and touch 0 infinitely on a negative axis, on a negative x and y axis, and it says no, I can't reach it. So then we try again on the right. It jumps down. It jumps back up here and goes from the right and goes, okay, well, I can't touch it here, no matter how much I try. And we're just going to keep getting less and less and less towards positive affinity, saying and the values are getting smaller, but they never touch 0. And that's the idea of an asymptote. So these have asymptotes. Okay. All right. And so and pretty much just say they limit a value. All right. And we'll talk about and that gets talked about when you guys talk about limits, and we use them a lot with squeeze theorem, and in fact all throughout calculus and other higher degree math. And so it's like the floor and ceiling as well of a function. So it's like a floor and ceiling, but we really uh, we'll get into that. Okay, so with that, all right, with general shape, all right, it looks like a polynomial, but we took out a value because all right, but we took out a value and dotted lines. All right, trying to prevent the function from being undefined. In fact, if we were to say if this were x, it would just be a linear line, and if this were x squared, if for any polynomial, it would be a smooth curve. All right, and so we say the domain of the function, the domain. All right, in this case, would be so for the parent function, it's negative infinity to 0, and we union uh, 0 to infinity. So pretty much the domain is and the range in fact Alright, so it's the highest the function will go. So negative infinity to 0, union 0 to infinity. Alright, but for the domain, it's alright, so we have two intervals. So the more asymptotes we have and the more values of 0 as we add on transformations we get, the more divisions we have in our intervals. Okay, so that's the main idea of that. So what videos could we expect in the next for the rest of this playlist? If you guys hear rattling, it's the wind outside blowing up against the window. Sorry about that, guys. Um, so the rest of for the rest of the playlist, we'll be talking about one asymptotes. Then we have the domain, calculating domain. All right. Then we have the transformations. And four, putting it all together. Okay. So we're gonna put it all together to really. Uh, so we'll put together the asymptotes, the domain, the range, the transformations, and to get the really general shape of the curve. Um, and that'll be actually and that'll be the next few videos. Also rational inequalities as well, because that's a skill you guys need to have too. All right. With that being said, guys, uh, that's all the time we have today. I'll see you guys next time. Later.